In this video we're going to talk about vectors. So let's start out with the definition. A vector has two things. It has something called magnitude, which is kind of another word for length, and it has direction. What we are familiar with working with would be something like a scalar. Scalar is like a number, like 5. A scalar only has magnitude. Okay, so let's talk about what that means and what a vector looks like. A vector is geometrically represented as a directed line segment. So it's a line segment that has a particular length or magnitude, and it has an arrow at one of the endpoints to represent a direction. So here I have a picture of a vector. It has 2 points, a starting point and an ending point. So that's what gives us what we call the line segment, and the direction is indicated here by this arrow. If you just had a line with 2 endpoints and you didn't have the arrow, then it wouldn't have direction and it would not be a vector. So your vector has to have this arrow on it to indicate its direction. Because we have the arrow, we can tell that the vector actually starts at P, and then we travel along that vector and the path ends at Q. So our points are labeled P and Q, and these points have certain names. So the point P, sometimes we'll call that the initial point. Initial meaning beginning. And we will call Q the terminal point, meaning this is where the vector terminates. Right, so if you call it initial point, the partner word for the ending of the vector would be the terminal point. So initial and terminal points. Some other terminology that you're likely to hear when you talk about vectors is head and tail. So if you were to imagine, let's say, an animal, I'll use a terrible picture of a dog. Yeah, so I probably should label this dog since it's kind of hard to tell what that is. But if you think about a dog walking along the path from P, so starting at P, walking along that path and then ending at Q, if you think about it like that, you think about the head as where the dog is heading, and that's where the dog would have its head, walking in that direction, and then its tail would be behind it, representing where the path began. Alright, so if you say head, then you say tail. Those are kind of partner terminologies for the beginning and ending of a vector. We can take this vector that we have with those endpoints that have been labeled 1, 2, and 4, 6, and we can plot this on a piece of graph paper if we wanted to. So I'm going to plot the point 1, 2. So there's our point P. And 4, 6. There's our point Q. So I'm going to connect that with a line segment. I'm going to put my arrow to indicate that direction. At the very heart of vectors really is the idea of movement. So thinking about the vector as a path that starts at P and moves in the direction of Q and then stops at Q. Another way to describe this movement is to think about it in terms of what we call components. So we want to break this movement down into horizontal movement and vertical movement. So we're going to separate those two ideas. So how much do we need to move, right or left, to get from the initial point P to the terminal point Q? So in this case I need to move to the right 1, 2, 3 units to get from P to Q. So our horizontal movement is a positive 3. If we would move to the right, then that horizontal movement will be considered positive. If we were to move to the left, then that horizontal movement would be considered to be a negative number. Okay, so since we're moving to the right 3 units, we put a positive 3 for that horizontal component. The horizontal component tells us how much we're moving and which direction we're moving in the x direction. Okay, and this comes from the idea, of course, that the x-axis is horizontal. That tells us movement from left to right. Okay, what about the vertical component? So how much do I need to go up or down to get from P to Q? So we go 3 to the right, but I go up 1, 2, 3, 4 units. So the vertical component would be 4. If that number is positive, we go up. If that number were negative, then I would go down. Or if I were to go down, that number would be negative. Okay? So the vertical component tells us the movement and the direction that occurs in the y direction. This is what we call the component form of this vector. So let's call this vector v. We like to use v for vector. And you'll see throughout the notes that there's a little arrow that's over the v. That is basically saying that's a directed line segment. So we have vector v, and we are going to use a new notation to describe the component form of the vector. So I'm going to use these little angle brackets to represent the vector. So the first number listed, 3, the second number listed, 4. The first number listed is going to be that horizontal movement from initial point to terminal point, and the second number listed is going to be that vertical movement from initial point to terminal point. So we call this the component form of the vector. So any vector can be described using this component notation. So at the bottom of your notes, it gives you some information about the component form. Okay, so when writing a vector in component form, we will say that vector v is equal to, we will use these angle brackets, and then we'll have this pair of numbers inside. The first number is represented by the letter a, and a is going to represent that x component. In other words, it describes the horizontal movement from initial point to terminal point. If that number is positive, then we move to the right. If that number is negative, then we move to the left. The second number listed is represented by b. b represents the y component. This is going to talk about the vertical movement from initial point to terminal point. If that number is positive, then we move up. If that number is negative, then we move down. So, for example, let's say that we had 3, -2 as one of the vectors. So there's the component form of a vector. So let's say that the initial point is here. So let's call that I for initial point. The movements, the first number listed would tell me to move to the right 3 units. So 1, 2, 3. The next number listed is -2. That would tell me to go down, because it's negative, 2 units. So that would represent the terminal point of that vector. So we would connect those 2 points to get our line segment, and the arrow always touches the terminal point. All right, so any vector can be described in that component form. So let's say that we are given the coordinates of the initial point and the terminal point. So we'll use x1, y1 to represent the coordinates of the initial point. We use x2, y2 to represent the coordinates of the terminal point. If we know the coordinates of the initial and terminal point, then we have a formula that can help us find the component form of that vector. To find the horizontal component, we're going to take the x value of the terminal point and subtract off the x value of the initial point. To find that vertical component, we're going to take the y value of the terminal point and subtract off the y value of the initial point. So let's go back up to our vector, see how that would look. So our initial point would be x1, y1. Our terminal point, we would call that x2, y2. So we're looking to figure out what's the horizontal distance. So what's that horizontal movement? To find that out, we're going to do x2 minus x1. So the x value of the terminal point was 4, minus the x value of the initial point is 1. 4 minus 1, we get 3. All right, so now we want to know what's that vertical movement. So we're going to do y2 minus y1. So the y value from the terminal point minus the y value from the initial point. 6 minus 2, we get 4. So that is exactly the same component form we had when we went to graph that vector on that piece of graph paper and count off the squares. Another question is, does the location of the vector affect the component form of the vector? So when we graphed this vector, we had 3 to the right, 4 up, and we plotted those coordinates, and we found the component form. Now, let's say that I move the vector to be here. You'll notice that if I move the initial point and the terminal points of the vector to be at different locations, the component form of the vector has not changed. It's still 3 to the right and 4 up. So moving the vector does not affect the two qualities of a vector. The two qualities of a vector being its length and its direction. So moving the vector does not change its length, it does not change its direction, and it also does not change the component form of the vector. One thing that we find to be convenient when working with vectors is to put the initial point at the origin 0, 0. If you put the initial point at the origin 0, 0, then notice something about the terminal point. So the initial point is 0, 0, the terminal point 3 to the right, 4 up, you'll notice that the terminal point is 3, 4. So the coordinates of the terminal point are actually going to match the components of that vector. When we plot the vector starting at 0, 0 as its initial point, we call that a position vector.